Hello. So in this lecture, we are going to continue with the series that is going on continuous functions. In the previous lecture, I did a question. I think there was a question regarding that. So I'll first resolve that and then we'll move on to the other questions as well. Okay. So a question was asked by a student. So let me just resolve it. Just give me a minute and I'll first find the question. Okay. So the question I asked was, we wanted to determine all the functions from R to R. We wanted to determine all the functions from R to R which are continuous and which follow the functional equation f of x plus y is equal to fx into fy. Okay, so from here, and it was given that f1 is greater than 0. Okay, and it was given that f1 was greater than 0. Okay, so let me just do it all over again. The main concern was, I'll just address that concern and I'll move forward. So basically the question was this: what I did was I wrote x, uh, because x is completely arbitrary real, so I can also replace x by x by 2 and y by x by 2. So basically it will give me this f of x. F of x will be simply f square x. F fx will be f square x by 2, and I wrote that it will be greater than equal to 0. So it will not be equal to 0. This I'll prove. Another thing that I said was this: the function cannot be identically 0. The function cannot be identically 0. Why function cannot be identically 0? Because if it is identically 0, then it will contradict this. Identically 0. Function cannot be identically 0. Although if it is identically 0, it satisfies your this functional equation. But since fx is identically 0, it implies fx is equal to 0 for all x belongs to R. So it must be equal to 0 for even for x equal to 1 also. But for 1, f1 is greater than 0. So we arrive at a contradiction. Therefore, it is not identically 0. But here I wrote that fx is positive on R. But one can say that f square x is non-negative. So non-negative means what? F square x, since it should be greater than or equal to 0. So what about 0? Can fx be 0 at any point? It is not identically 0, which implies it is not 0 for all x belongs to R. But can it be identical? Can it be 0 for any point? 0 at any point. This is something that concerns the construction also, because lately I constructed a function gx which is log fx. So the student asks, what if at one point it is equals to 0? Overall you are claiming it is non-zero. So even for one point if it's 0, then this construction cannot be made. So here I'm going to address this concern that fx cannot be 0 even at a single point. Why? So let me assume that there exists a point x naught such that fx naught is equal to 0. I am saying that there exists a point fx naught. There exists a point x naught where fx naught is equal to 0. So if that's the case, what I'll do, I'll simply write this 1 minus x naught plus x naught, and it will be equals to what? It will be equals to this. I take 1, so this will be fx naught, and here it will be f of 1 minus x naught. So on the left hand side you have f1. So f1 is equal to what? It is equal to fx naught into f of 1 minus x naught. But we already know this will be 0 and this is something greater than 0, so we arrive at a contradiction. It implies there does not even exist a single point where fx is 0. It implies fx, which is equals to f square x by 2, it is certainly greater than 0, not even equal to 0. Not even at a single point it will be 0. So which allows us to write a new function gx, which is log of fx. And since fx is non-zero, sorry, since fx is positive, since fx is positive, we can always construct this function gx, and from here we can build up that g of x plus y will be simply log of fx plus y, and we know that log of fx plus y is log of fx plus log of fy, because we know that f of x plus y is fx into fy, so this is this, and this we know that g of x plus y is equal to simply gx plus gy. So we understand that gx satisfies the Cauchy's functional equation, and since it satisfies the Cauchy's functional equation, gx satisfies the Cauchy functional equation, it implies that gx must be some linear function. So gx must be equals to what? This is, so fx must be equal to what? Fx must be equal to something like this g1 is what? It is log of f1, and this is into x, so I'll write x here. So basically, sorry, this is log of fx. So this is log of fx will be equals to what? It will be equals to f1 raised to power x. And from here by we can write, since fx is a 1 function, so fx must be equal to f1 raised to power x, and this f1 I'll write something like b or something. So fx is equal to b raised to power x, and it will be strictly greater than 0 function. So all exponential kind of function are going to satisfy this above functional equation. So this is one important thing one has to note. uh, it was asked by one of the students. I redid it. Okay, now today we are going to do a certain category of question which will help you a lot. So let me start with that. And uh, and these are this is a quite important thing, quite important assertion, that's why I'm going to do it. So let's say let a function be defined from R to R be a continuous function, be a continuous function such that fx is equal to fx square for all x belongs to R. Then f is a constant function. This is what you have to prove. F is a constant function. So let me do it. Just give me a minute before I start it. So let fr to r be a continuous function such that fx is equal to fx square for all x belongs to r. We have to prove that if such is the functional equation, that is fx is equal to fx square for all x belongs to r, then f must be a constant function. Then f must be a constant function. How to prove this? So what I'll do, okay, what I'll do, so let x be greater than 0, and then by hypothesis one can write, then by given hypothesis one can write that fx will be equals to fx raised to power 1 upon 2, because you know that fx square is given to be fx. So if x is greater than 0, the square root of a number is defined. So fx is equal to f of x by 2, and f of x by 2 according to this given hypothesis will be f of x raised to power 1 by 4, and this will be f of x raised to power 1 upon 8, and so on and so forth. I can write f of x raised to power 1 upon 2 raised to power n. And we know that 1 upon 2 raised to power n is a subsequence of, it is a subsequence of 1 upon n when n varies from 1 to infinity. We know that this turns to 0, so therefore 1 upon 2 raised to power n also turns to 0, so 1 upon 2 raised to power n turns to 0. So it implies that x raised to power 1 upon 2n converges to 1. Since f is a continuous function, we know f is a continuous function, so we can say that f of x raised to power 1, x raised to power 1 upon 2n converges to f1, and we know that this is equals to what? This is equals to f of x ultimately. So it implies that fx will be equals to f1 for all x greater than 0. This is one thing. Okay, now what about x less than 0? What about x less than 0? So we know that whether you write fx or whether you write f minus x, so f minus x will be equals to f minus x ka whole square, which is certainly equals to fx square, and fx square is again f of x. So whether you write fx or f minus x, they are one and the same thing. So since f of x is equal to f of 1, it implies that f of minus x for all x greater than 0, f of minus x will be equals to f of x, and which is equals to f1. So if for all x greater than 0, f minus x is equal to f of x and f of x is equal to f1, so it implies fx is equal to f1 for all x greater than 0 and for all x less than 0. And what about f0? Since f is continuous, since f is continuous at x equal to 0, so I can write that limit on the right hand, limit h tends to 0, f of h must be equal to what? F of 0. And what is f of h? F of h, because it falls in this definition, for all x greater than 0, fx is f1. So fh, even as small as possible, this will be equals to what? 1, because this is positive. So f1 will be equals to f0. It implies that fx is equal to f1 for all x belongs to R. It implies what? It implies that fx is a constant function. Okay, so this is one of the important question. So again, I'll try to solve a few questions based on such approach, and this will help you a lot. Okay, so let me do another question for you. We want to find all the functions continuous functions, sorry, find all the continuous function such from R to R, from R to R, such that f of x plus f of 3x is equal to 0 for all x belongs to R. So we want to find all the continuous functions from R to R such that fx plus f3x is equal to 0 for all x belongs to R. So given this hypothesis, we first understand, given this hypothesis, we understand that f of 0 will be equal to 0. How come? Because if I write x equal to 0, it implies 2f0 equal to 0, and which implies f0 equal to 0, because it is true for all real R, so it must be true for 0 also. And if it is true for 0, it implies that f0 must be equal to what? 0. So this is the first thing that I'm writing. So f0 equal to 0. Okay, is that fine? Okay, now we claim here that fx being identically 0 is the only function which satisfies the above functional equation. Okay, we are claiming that this is fx being identically 0 for all x belongs to R is the only function which satisfies the above functional equation. Let's see how. See, what is given to us is given to us that f3x is equal to minus fx. Okay, f3 is equal to what? Minus fx. And if I see from here, fx will be equals to what? It will be equals to minus minus plus f of x by 3. Okay, it is x, it is 3x. So it is 3 times this. So 3 times f, so this will be like, if I just think about this, if I just write y by 3 here, so it is y by 3. So fy plus fy by 3. So basically fy will be equals to minus of f of y by 3. So minus here and again minus. This will be this. And this, if I think, this will be minus f of x upon 3 square. See, f of 3x simply here from here. If you are not able to understand, I'm writing it here. So f of 3x will be equals to what? F of 3x will be equals to minus fx. And what will be fx? If I just write here x by 3, so it will be minus of f of x by 3. So if fx is f minus of f of x by 3, so minus fx will be equals to what? It will be equals to f of x by 3. So it will be equals to what? It will be equals to f of x by 3. And what will be f of x by 3? It will be minus of f of x upon 3 square, so on and so forth. On the same, like following the same, it will be equals to what? It will be equals to f of x upon 3 raised to power 3. It will be equals to what? Minus of f of x upon 3 raised to power 4, so on and so forth. So if I want to compare what will be fx, so from here it is clear that fx will be equals to what? Fx will be equals to minus of f of x upon 3. Okay, again negative, negative, positive, f of x upon 3 square. This will be minus of f of x upon 3 raised to power 3. This is f of x upon 3 raised to power 4 dash dash dash. So similarly, seeing the pattern, I can write it as equal to minus 1 raised to power n f of x upon 3 raised to power. So clearly f of x will be equals to what? Minus 1 raised to power n f of x upon 3 raised to power n for all x belongs to R. This is true because of the given functional equation, and we already know that f of 0 equal to 0, and we also know that f is continuous. Now see, as n tends to infinity, we understand x upon 3 raised to power n will tend to 0 for all x belongs to R. And from here we know that f of x upon 3 raised to power n will converge towards f of 0, since f is continuous and f of 0 equal to 0. It implies what? F of x will be equals to 0 for all x belongs to R. It implies that only function being identically 0 satisfies the given functional equation. So there is only one such continuous function which satisfy this type of functional equation. I hope this is clear to you. If I complicate it all the more, if I want to complicate it all the more, what I'll do, I'll simply give another question of the same category, and let's see how it goes. See, we want to find all the continuous functions, find all the continuous functions from R to R which satisfies the given functional equation f of x plus f of qx equal to 0, where mod q is less than 1. Okay, so according to this hypothesis, what will happen? So according to given hypothesis, we understand that f of qx is equal to minus of fx. So this we know that, or we can say that f of x, it is nothing but it is equal to minus of f of qx. If I replace qx here, so f of qx will be equals to minus of f of q square x. Okay, just give me a minute. So sorry for the disturbance. So f of qx will be equals to minus of f of q square x, and if you want to continue it further, f of q square x, it will be minus of f of q cube x, and so on and so forth. So what I can write from here, that f of x will be equals to minus of f of qx. F of qx will be minus of f q square x. This will be plus f q square x, f q square x. So this will be minus of f of q cube x, and this will go on, so on and so forth. So I'll write it as minus 1 raised to power n f of q raised to power n x. And we already know that mod q is less than 1. Since mod q is less than 1, then n tends to infinity, q raised to power n, this will be equal to 0, or in other words, q raised to power n x will be equals to 0. This limit will be equals to 0 for all x belongs to R. And we know that function is continuous. It implies f of q raised to power n times x. This will be equals to f0. And we know that f0 is simply 0. From here it is known that f0 is 0, because if you replace x by 0, this will be 2 times f0 equal to 0. It implies f0 is simply equal to 0. Since f0 equal to 0, it implies fq raised to power n x is equal to f0, and we know that fq raised to power n x, this particular fellow, if it is 0, it implies that fx is equal to 0 for all x belongs to r. So for this functional equation also, fx being identically 0 is the only function which satisfies the given hypothesis. Okay, is that fine to you? I think this is easy. So we don't have to worry about all these things. These are easier questions. We just have to follow the given definition and try to solve and use the continuity argument at that. So basically, this is how it is done. These are not that difficult. So basically, iterative approach and the continuity of the function both will serve as a guiding light to these questions. Not a problem. So let us do another question so that it enlightens you all the more. So we want to find all the functions. Sorry, again I say functions here. So find all the continuous functions. Find all the continuous functions from R at 0. So we want to find all the functions, sorry, we want to find all the functions which are continuous at 0. We want to find all the functions which are continuous at 0 satisfying the equation that f of x plus f of 2 upon 3x is simply equals to x. We have to find all the functions which are continuous at 0 and satisfying this thing, fx plus f of 2 upon 3x is equal to x. So we want to find all these functions. So let us do that. Okay, so first thing that is observed that f0 will be equals to 0, because if we place at x equal to 0, this will be f0, this will be f0 is equal to 0. It implies 2 times f0 equal to 0. It implies that f0 equal to 0. Okay, now from the given question, I'm going to do again using the given question only, given hypothesis only, we can write that f of x is equal to x minus f of 2 upon 3x. So f of x is equal to x minus f of 2 upon 3x. What about f of 2 upon 3x? If I replace x by x by 2 upon 3, so this will be 2 upon 3x, and this will be minus of f of 2 square upon 3 square x. And we know that what is f of 2 upon 3x? So we know that if I want to write it in this fashion, so if I want to write what is f of 2 upon 3, so f of 2 upon 3 is nothing, but it is equal to x minus f of x is equal to 2 upon 3x minus f of okay. So if I want to write what is f of x, so f of x will be equals to this minus minus becomes positive. So this is f of okay. So this is my equation number 2. Okay, so f of x will be equals to f of 2 square upon 3 square x minus 2 upon 3x plus x. Okay, now what will be f of 2 square upon 3 square x? So it is simply, if I put here 2 upon 3x, so this will be f of 2 square upon 3 square x, because you know this is true for all real r. So this is true for all real r's. So if x is real, then 2 upon 3 times x is also real. So instead of x, if I place 2 upon 3, so this will give me f of 2 square upon 3 square x. So if I place here 2 upon 3x, this will give me 2 square upon 3 square x minus f of 2 cube upon 3 cube x. So basically in this place, if I write 2 upon 3x, so this will give me this. Okay, and this f of 2 square upon 3 square x, so if I just write it here, this, if I replace this equation number 3, if I write this as equation number 1 itself, so if I replace equation number 3 into equation number 2, I'll get that f of x is simply equals to minus of f of 2 cube upon 3 cube times x plus 2 square upon 3 square x minus 2 upon 3x plus x. Okay, this is equation number 4. And if I want to continue likewise, what will I get? So if it is 2 cube 3 cube here, it is 2 square 3 square here. So if I just write this way, fx is nothing but it is equal to minus 1 raised to power n f of 2 raised to power n upon 3 raised to power n times x. And then you have this thing. See, from here you have if n is here, n minus 1 is here, so I'll simply write 2 raised to power n minus 1 upon 3 raised to power n minus 1 times x, and negative is here, then positive is here. Okay, so what I'll do, if minus 1 is here, then it is a positive here. So if minus is here, then it is a positive here, and if it is positive here, then it is minus. So if minus 1 raised to power n is positive, if minus 1 raised to power n is positive, then minus 1 raised to power n minus 1, this will be negative. Are you getting my point? So I'm trying to generalize this. Uh, in, okay, so I'm going to generalize this plus minus 1 raised to power n minus 2, 2 raised to power n minus 2 upon 3 raised to power n minus 2x, 2 square upon 3 square x minus 2 upon 3x and plus x. So what I can see, what I see from here is that f of x, from here I'm writing. So what is f of x? So f of x is equals to minus 1 raised to power n f of 2 raised to power n upon 3 raised to power n times x plus minus 1 raised to power n minus 1, 2 raised to power n minus 1 upon 3 raised to power n minus 1 x plus minus 1 raised to power n minus 2, 2 raised to power n minus 2 upon 3 raised to power n minus 2 x dash 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 2 square upon 3 square x minus 2 upon 3x plus x. Okay, now so as n tends to infinity, 2 upon 3 whole raised to power n x, this tends to 0, and we know that f is continuous, so f of 2 raised to power n upon 3 raised to power n times x, this tends to f of 0, and we know that f of 0 equal to 0, so this will go towards 0. And now a function we are left with this is this is nothing but fx is equal to x minus 2 upon 3x plus 2 square upon 3 square x minus 2 cube upon 3 cube x, and at the end we have minus 1 raised to power n minus 1, 2 raised to power n minus 1 upon 3 raised to power n minus 1 x. So basically if we take x common, what we'll get? We'll get x bracket 1 minus 2 upon 3 plus 2 square upon 3 square minus 2 cube upon 3 cube dash 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 minus 1 raised to power of n minus 1, 2 raised to power n minus 1 upon 3 raised to power n minus 1. Okay, and so if we solve this, this is geometric progression, so and with the common ratio minus 2 by 3, so fx will be equals to x into 1 upon, we know that if we are having a plus ar square plus, sorry, a plus ar cube, and also if we have a plus ar plus ar square dash 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 arn, and these n tends to infinity, then the answer, and if mod r is less than 1, this sums up to a upon 1 minus r. So here instead of r we have minus 2 by 3, so this will be x into 1 upon 1 minus of minus 2 by 3, so this will be this, so f of x will be simply 3 upon 5x. So this is your function, this linear function, that is fx is equal to 3 upon 5x, will satisfy this particular uh, functional equation. Further, it is also continuous at 0. This is a linear function. This is continuous for all x belongs to R. So such questions may be asked in your examination. Okay, another one just to solve and just to help you out. And these are all very easy questions, not difficult ones. Okay, these are not difficult ones. I think you can do all these questions. See what we want to determine, and then we'll do a question which was asked in NBHM exam also. So determine all functions from R to R such that f of 2x plus 1 is equal to fx, and fx is continuous at x equal to minus 1. We want to determine all the functions from R to R such that it satisfies the functional equation, which is f of 2x plus 1 is equal to f of x, and further f is continuous at minus 1. So all these attributes are there. We want to find all the continuous function which satisfies both of these things, that is f of 2x plus 1 is equal to f of x, and also that f of x is continuous at minus 1. Okay, so how would we do that? So what I'll do, I'll simply use something like this. So we'll set something according to this particular definition. So what I'll do simply, I'll simply write that let us define a recurrence such that x1 is equal to x, and in general xn plus 1 is equal to, seeing this, it is equals to xn minus 1 upon 2. So if you think this is 2 times xn plus 1, 2 times xn plus 1 equal to xn. So basically, and we know that as n tends to infinity, whether you say n plus 1 or you say n, it is same, both of them are tending to infinity only. So we have assumed a relation between xn plus 1 and xn such that xn plus 1 is defined as xn minus 1 upon 2, and here x1 is equal to x. See what I'm doing, you'll be able to understand as I'm going through. See, I understand that as n tends to infinity, the as n tends to infinity, whether I write xn or whether I write xn plus 1, both will turn towards L only. So I'll simply write it as xn only. So xn 2xn will be equals to xn minus 1. So it will be equals to this. So as n tends to infinity, my xn limit will be equals to minus 1. So this particular recursive sequence at where xn plus 1 is equal to xn minus 1 upon 2 is a converging sequence such that xn converges towards minus 1, and we already know that f is continuous at 1, which implies that f of xn will converge towards f of minus 1. Further, we also know that what is f of xn? F of xn is nothing but it is equals to what? F of xn is nothing but it is equals to f of 2 times xn plus 1 plus 1. And we already know that f of 2x plus 1 is equal to f of x. So this will be equals to what? This will be equals to f of xn plus 1. So what we have arrived at, we have arrived at that f of xn plus 1 is equal to f of xn. F of xn will be equals to f of xn minus 1 dash 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 will arrive at f of x1, and we know that x1 is equal to x, so it implies that f of x will be equals to f of xn plus 1, and we know that as n tends to infinity, xn plus 1 or you can say xn converges towards minus 1. It implies that function is, since function is continuous, at minus 1 f of xn plus 1 converges towards f of minus 1 as n tends to infinity, and this is true for all real r. So it implies that f of x is equals to f of minus 1 for all x belongs to r. It implies that fx is a constant function. So all these things are very important things. All these questions are very important questions. So what I did, again, I'm reiterating. See, according to this particular expression, we just thought of a recursive sequence. So just think about this. 2x plus 1 is equal to x. So it implies, if I solve it a little bit, 2x plus 1 is equal to x. So 2x is equal to x minus 1, and then you divide it. So basically what I did, I used this thing that as n tends to infinity, whether you write xn or whether you write xn plus 1, this is one and the same thing. So I just defined a recursive sequence. Define a recursive sequence xn plus 1 is equal to xn minus 1 upon 2. And while I define it, I understand that n tends to infinity, xn will converge towards minus 1. This is very much clear. Because as n tends to infinity, xn will convert, whether you say xn or xn plus 1, both will converge towards L. So this will be equals to L equal to minus 1. It implies as n tends to infinity, xn will be equals to minus 1. And we already know that function is continuous at minus 1. It implies f of xn will be equals to f of minus 1. Now, f of xn is not only equal to f of minus 1, rather f of xn is also equal to f of 2 times xn plus 1 plus 1. So basically f of xn is equal to 2 times xn plus 1 plus 1. And according to the given question, for all x belongs to R, 2x plus 1, f of 2x plus 1 is equal to f of x. So basically f of 2xn plus 1 plus 1 is equal to f of xn plus 1. So f of xn plus 1 is equal to f of xn. F of xn will be equal to f of xn minus 1, so on and so forth. And we'll get this is equal to f of x1. And what is x1? x1 is equal to x. Here x can belong to any real number. So basically fx is equal to f of xn plus 1. As n tends to infinity, we understand that xn plus 1 or xn both converge towards minus 1. It implies that fx is equal to f minus 1. It implies that f is a constant function. Okay, so these questions are very important, and one must, whenever you are studying continuous function, at least whatever I have taught you so far, you should take all these things with great regard. Tomorrow I'm going to solve a few more questions, a couple of them, and then we'll move to the newer topics. Okay, till then, take care. Bye bye.